Hey everyone, welcome back to my channel 3 Dash. Guys, I had not posted any videos from last few months, but in this new year I'm going to start again my Fusion 360 exercises. So for today's video, let's move on to my screen. I will show you in this video we are going to practice a sheet metal design today, and I'm going to choose a random design from the internet. So let's get back to my screen and let's see what I'm going to model today. So I will just search in Google sheet metal design. Here you can see, and I will go on to the images over here, and here you can see there are multiple designs that you can try, but I had already planned a design on these images. So I will just go and look for the design. So here you can see this is the simple bracket, so we don't have any dimensions or any measurement or any specification for that, and we are going to consider everything for this particular design, and we'll start modeling into Fusion 360. So here you can see this is a very simple bracket. If I open this design is from thefabricator.com, and if I go to the bottom over here, they had a complete detailed article over this, and then we had this image. So I will just open this image on my screen, and I will try to make this screen little larger if possible. What I can do, I can just save this image on my desktop. Here you can see I had just saved my image on my desktop. Now I will just move on to my desktop and I will open this. Here you can see, so this is the image that we are going to practice today, and I will just going to make it a little bit bigger. So here it is. Now we'll move on to our Fusion 360. So whenever you will first launch your Fusion 360, it will look something like this. So here you can see this is the default screen of Fusion 360, and if I click on here on this left top corner, here you can see I can access my data panel. So here is my folder where I used to record and save all my YouTube files for Fusion 360 especially. So I will just double click and go on to that particular project, and here we had multiple projects already saved over here. So I'm going to create a new folder and we'll give it a name. Let's write it sheet metal bracket. Here you can see the folder has been just created. You just have to rename the folder like you do for any other folder in your Windows or desktop computers. So I will just double click to go inside this particular folder, and what I will do, I will save this particular file that is not having any kind of design or sketch for now. So I will just save this empty design into this folder. So I will just click on the save here, and you can also save this file by going through the option over here inside the file. If you click on the drop down here, you can click on the save over here as well, or you can also use your keyboard shortcut Control plus S keyboard keys on your keyboard to save this file. So I will just use the very simpler option, that is to clicking over here on this save icon. So you can see, now you can see it's saving in the right location. You can just confirm the location from over here, and if you want to change, you can also change the location, but I will just keep it for now because it's the right location for now, and I will give it a name metal bracket. Here you can see, and we'll click on the save, and in just few seconds you will able to see that your file is getting saved over here in the cloud inside Fusion 360. So you can access this file from any computer across the globe, across the world. If you have access to Fusion 360, you just have to log in into your Fusion 360 using your Autodesk user account, and you will be able to access this file. So now the work of this data panel is over. So I will just close. I will click on this close data panel over here, and it's closed. Here you can see it's hidden on the left side. Still, if I want to access, I can just click on here and I will able to access that data panel, my all files that I had saved in that particular folder. So since I'm going to do this bracket, here you can see this bracket in a sheet metal work environment, sheet metal design. So inside my Fusion 360 we have multiple workspaces. So I will just right now by default the solid workspace is active. Here you can see inside solid we got multiple tools, so we had to move that to sheet metal workspace. So I will just click on the sheet metal over here, and here you can see we got different tools now. So before starting any sheet metal design, the first thing that we had to do is that we had to check the sheet metal rules, that what are the sheet metal rules we are going to follow. So I will click on the sheet metal, and here you can see we got different kind of sheet metal predefined library. Here you can see with the different kind of material and their thicknesses. So even I can create a custom one by clicking on over here on the new rule. If I want to copy this particular style and want to edit and create a new material or thickness, I can just click on the new rule. Also I can edit this default one as well. So for now I'm just going to use this cotton steel, so I will just close it, and then what I will do, I will click on this new component option. So before starting any of my design or anything, first thing we always do is to create a component, empty component. So I will click on this new component option over here, and here you can see we are just going to work in a sheet metal workspace, and then the component name, so I will just rename it as a bracket. And here you can see from the sheet metal rules we had already selected this cotton steel, that is 2 mm thick sheet metal, and I will press OK. So here you can see the new component bracket has been created, and inside that our sheet metal rules are also defined. So whatever I am going to design inside this will be already applied with the properties of this particular rule. So I will just hide this option over here, and I will turn on the origin as well. So here you can see this is my default origin over here with the 3 planes and 3 axes, XYZ axis and 3 planes. So what I will do, I will start with a basic sketch over here. So I will just click on the create a sketch over here, and then I will select the plane. So this is the top plane where I'm going to create my first sketch. So I will just click on the top plane over here, and here you can see the plane is active and our sketch tools are also active, and our sketch environment is also active. So we'll able to create a sketch inside this. So before starting this bracket, I'm thinking to start this bracket from this face. Here you can see right now from this face we'll able to start this bracket. So this is the final design that we'll try to achieve. So just forget about ABC options, we are just going to model this D option. So this one looks little complex, but it's very easy to model. So we'll model this particular bracket, and I am assuming that this bracket is of size 50 mm by 50 mm, or we can also think that maybe 100 mm by 100 mm. This bracket size is 100 mm by 100 millimeters. So we are going to first create this base, this face over here. Here you can see, so this is the first thing that we are going to model. So for that we'll go on to the rectangle tool over here, inside this drop down, inside the create a sketch. Here you can see, and inside the rectangle tool we got different kind of rectangles. From there we are going to use this center rectangle tool. I will just click on this to activate the tool. Here you can see the tool is active. Now I will select the origin and I will create a rectangle of 100 millimeter. Then I will press tab to move on to the other side, and again we'll write 100 and we'll press enter to accept. Here you can see, very simple. It was very simple to create a sketch inside Fusion 360. In just few seconds I had created this rectangle of 100 millimeter by 100 millimeter, and once I will click on the finish, it will automatically apply sheet metal thickness of 2 millimeters, since it's based on our rules that we had selected for the steel. So I'm going to just click on the finish over here, and here you can see our sketch is ready. Now I will just click on this flange option here, and then we'll select the sketch, and here you can see it has automatically applied the thickness of 2 millimeter based on our rules that we had created. And I will just press OK. Here you can see. So here are few things that you have to notice while applying flange tool from the here, and a few more things that I want to tell you at this point is that whatever the operations you are doing, like this sketch creation or the applying the flange tool, is all getting recorded below over here. Here you can see, so this is all called design history. So if you want to just go back to your design process, you can just click on this arrow over here and you can drag it towards backward. So it will keep pushing you on the one step back on every history over here. So if you just want to go back and make changes to any of your design steps, you can just come over to your design history and make a right click, and from here you will able to edit your whatever the operations you did. So if I want to edit my sketch, so I can just click on this sketch icon, and I will be able to click edit sketch. So here you can see my sketch tools are again active, and if I want to make a change, like if I want to make this one 80, I will able to make I will able to do that. So I'm not going to make any changes for now, so I will just press Ctrl J to undo the things, and I will click on the finish sketch. Here you can see what I'm going to show you here at this point is I will just make a right click on this and we'll click on this edit feature, this edit flange feature, And here you can see when I had applied the flange on that particular sketch, there is a option called orientation that you had to always take care of. The orientation is actually in which side you want to give thickness to your sketch. If you see from this view, this is actually the view cube from where you can navigate your 3D model. So you can see if you click on this top, you will be on the top view. If you click on this over here, it will be on the front view. So we are in front view right now, and here I wanted to show you what is the effect of this orientation option over here inside this flange tool. So right now it is side 1. If I want to change that to side 2, so here you can see it is just giving a thickness of 2 millimeter on the other side. If I want to change this to center, so it is evenly distributing that thickness across the plane. You can see that. So this is the way you can keep your design so that you will have a full control of your on the design sizes. So that's why I told you that the orientation option is very important to understand. And now I will just press OK to accept the result, and here you can see so this is the basic flange that we had created. And if I move on to our image over here, so we got center hole at the center. Here you can see this big hole, then 4 holes distributed equally along, I think on 90 degrees. So we are going to create this one next. So I will just move on to our Fusion 360 again. We'll go on to the top view from here, and again I will activate my sketch tool, and this time I'm going to select this face, this top face of our base flange as a sketch plane. So I will just click on this face, and here you can see that face is active too, so that we'll able to create any sketch on over here. So on the center I will just create a circle like this. So this circle I want to keep 50. So randomly I had created a circle of any dimension. Then I will activate my sketch dimension tool, then we'll define the size of this one as 50. Here you can see. So now it is constrained. And if I expand my component from here, you can see inside the sketch folder, this is the second sketch that we are working right now, and the sketch 1 was the base sketch that we had already used to create the base flange. So now we had to create these 4 circles over here. You can see equally distributed on 90 degrees. So for that we are going to start with a circle. So here you can see I'm going to create a circle following the same center like this, and this one I'm going to define the dimension as maybe 75 millimeters, or maybe little lesser, maybe 70 millimeters, and like this. And I'm going to change this one as a construction line. So I will select this circle, and from here I will able to apply that, I will able to change that to construction. So you can see now I'm going to create 4 circles that are equally distributed at 90 degrees. So for that, first thing I'm going to create a line. So I will just activate the line tool, and we'll create a line like this. Here you can see, here you can see I will change that line to construction line like that, and I will make one more line from here to here, and we'll make sure that this line is horizontal, and we'll change that to construction line. Here you can see now I will define the angle between these 2 lines. So this one we just want to give 45 degree. So here you can see we got the point over here. So at that particular point we are going to create new circle like this. Now I will define the dimension of that particular circle. So this one just I want to keep 6 millimeter, and or maybe 7.5 millimeter like that. Then I will select that particular circle, and will activate my circular pattern tool, and will select the center point, and this one I want 4 in a number that must be equally distributed on 360 degree. So here you can see 4 numbers equally distributed on 360 degree, and we'll press OK. So you can see this is the way we had created this. Now what I will do, I will just click on the finish sketch, and now I will just select all the 5 profiles that I want to make a cut. And if I drag it to the other direction, here you can see by extruding those all 5 profiles I am able to make a cut. And if I press OK, so here is my final result. So we had just created this particular face. Now we'll move on to creating this particular face, and now we'll move on to creating some other faces. So for this face, these are also the same measurements, I think, the same lengths, I think. So this is also 100 millimeter long, this is also 100 millimeter long. So I will move on to my Fusion 360, and will activate my flange tool again, and will select the corners that I want to extend. So these are the 2 corners that I want to extend, and these are the 2 corners that I want to extend up to 100 millimeters. So I will give here the height as 100 millimeter, and here you can see if I press OK, so this face has also been created. So we had created some of the parts over here of our Fusion 360 sheet metal project, and now the next thing is that we also had to create these faces at the bottom, but here you can see we had a small gap on the center, so we had to maintain that as well. So we'll see carefully over here that what are the things that we are to extend over here, and then we'll move on to our Fusion 360. Again, we'll select both the flanges, both the edges that we are going to make a flange. Then we'll activate my flange tool and we'll make a thing like this. Here you can see it's automatically making the shape, and we'll make sure that both of them are having some gaps. So instead of 50, if we make 50, it will be automatically just joining the two edges. So instead I will make 45, so in that case, or maybe 47. So sorry, it must be 47, not 447. And here is the design with some gap, and we'll press OK. So here we got. And the next thing is that we had to create few more things. If I move on to our design, so we got two holes over here, and then a hole at the center, and then this edge also here you can see it's not a corner edge, it's already chamfered. So the first thing that we're going to apply chamfer on these two edges. So for that we'll move on to modify option over here, and we'll activate our chamfer tool, and we'll select the corners that we want to apply chamfer. So here we just want to apply chamfer of 75 millimeters. So here you can see this is the shape we are getting, or maybe 80 millimeters. I think it is good, and I will just press OK. Here you can see it's equal distance chamfer, so we got multiple kind of different chamfers, even the two distance chamfer or distance and angle chamfer. So you can try those as well, what are the effects you are getting. So this time I'm just going to use the equal distance chamfer, and I will press OK. So here you can see this is the result. Now we had to make these holes. Here you can see these are the holes that we had to create. So for that I will just select one of the face on this bracket, and then we'll click on the create a sketch, and we are just active on that particular face. Here you can see. Now I will start creating those sketches for those holes. So one circle over here, then two more circles over here and here. So we'll make sure that I'm creating two more circles like this. Here you can see. Now I will make sure that these two circles are equal. So I will just by pressing shift on my keyboard, I am able to select both the sketch, and then I will press apply the equal constraint. So both of them became equal. Here you can see. Now I will define the position of the circle from this edge to the center of the circle. Let's do this again. Center of the circle and this edge, and this one I just want to keep 30. And we'll do the same on the other side, center of the circle, then this one I want to keep 30 as well. Now I will define the diameter of this particular circle. So this one I just want to keep maybe 30-40 like this, or maybe 35 will be good. Yeah, that is good. Now we'll define the position of these two circles from the edges. So from center to this edge I just want to keep 25, not 25, I think it must be 20 or even lesser, 17.5 like this. And from this edge I will keep this one as from center to this edge, this I am going to keep as 25 like this. We'll do the same for on the other side, from this edge to the center of the circle. This one I just want to keep 25, and from the center of the circle to this edge, this one I just want to keep 17.5 like this. And I will also define the diameter of these two circles. So this one I just want to keep 10 like this. And if I click on the finish the sketch, here you can see this is my sketch. Now I can just activate my extrude tool from here, and will select all the three profiles that I want to make a cut, and will drag it like this, and will make sure that it is coming on the other side of the bracket as well. Here you can see, so it is cutting thoroughly on the other side of the bracket as well. And if I press OK, so it will take few seconds, and here is our final result. So I think we are getting closer. So the only difference that we are getting in our design is that the thickness, like the thickness over here is different, and whatever is looking in our design, it is little bit different. Now the next thing is that we are going to work on this particular face. So we are going to get this, we'll try to get this kind of shape now on our design. So for that again we'll move on to our Fusion 360. We'll click on over here to create a sketch, this face, and then again I will click on create a sketch, and here you can see now we had to create 3 circles on this particular edge. One circle like this, and we'll create one more circle like this, and we'll create one more circle like this. Sorry, not like this, actually what we think, one circle will be like this, but the other 2 circles will be like, I think it must be touching to the edge. Here you can see like that, and we'll make sure that this circle is also touching to this edge. So we'll select the circle and this edge by pressing shift on my keyboard, and we'll apply the tangent constraint like that. We'll do the same on the other side. We'll select the circle and this edge, and we'll apply the tangent constraint like that. And we'll also make sure that all the 3 circles are touching. So we'll select all the 3 circles like this, or what we can do, we can select 2 at a time. We'll select these 2 circles, we'll apply the tangent constraint like this. We'll select these 2 circles and we'll apply the tangent constraint like this. Now what I will do, I will select all of the 3 circles and we'll make sure that all of them equal. So we'll apply the equal constraint, or I think what I will do, I will make sure that these 2 circles are equal. So we'll apply the equal constraint between these 2 circles. It's not working anyway, so what we can do now is we'll keep it like this, no problem. We can define the diameter of the circles. So this one I just want to keep 30. So here you can see this is 30, or maybe a little bit higher, 35. I think 35 is good. And here you can see we are getting the shape. Once what I will do again is that I will just click on the finish sketch over here, and here you can see, and then I will activate my extrude tool. Will select these profiles that I want to cut. There you can see, and we'll drag it towards downward to make it cut. Or before that, I just want to make sure that I had also created these 2 holes, so we'll not have to create any more sketches. So for that I will just go on to my sketch. We'll click on the editor sketch again, and on the centers of these circles we'll create 2 sketches for the holes, and we'll make sure that these 2 are equal. So we'll apply the equal constraint, and then we'll define the diameter of this particular circle. So this one I'm going to keep it as a 10 millimeter in diameter. Then we'll click on the finish sketch again. We'll orbit it a little bit, then we'll activate the extrude tool. We'll select the profiles, it's pretty easy, and then I will also select these 2 profiles and we'll drag it towards downward. So here you can see this is the shape we are getting, and if I press OK to accept, here we go. So this is what we got after applying all the operations, and we want the same thing on the other side as well. So I will just select this particular operation that we had performed. We will go on to the create option over here, and we can select the mirror tool, and we just want to mirror this operation on the other side as well. So for that we had to specify the mirror plane as well. So we'll activate the mirror plane, and this is the plane that we are going to select as a mirror plane. So we'll select that plane. So, and here you can see we are getting a preview as well. So I will just press OK to accept the result, and this is what we got. So we had just finished our design that we had seen in this particular Google search. Here you can see, or in this particular search. So this is what we had created. So in this design, if you can see carefully, there are these corners that are already filleted. They are not very sharp, so we can apply that as well, and then we'll try to match the thickness of this particular thing. So what is the benefit of using sheet metal design process? I will show you now. So first let's apply the fillet on these corners, all the 4 corners. So I will just select all these 4 corners like this at once, and then we'll apply the fillet radius. So I just want to keep fillet radius of 5 or maybe 7.5 like this. So here you can see, so things are now smooth, very smooth. Now the things are looking very good. So now I will show you the power of the sheet metal rules. What is the benefit of using this process? So let's say if you want to change the thickness of this complete bracket, if you are not happy with this thickness, or if you had performed any kind of simulation or load test and you are getting a result that this will not be able to sustain that particular load, so in that case you had to increase thickness. So you cannot repeat the design process again, it will take lots of time. So in case of sheet metal, what you can do, you can increase your thickness in just a single click. So let's see how we can do that. So now we'll move on to over here. Here you can see we got the sheet metal rules. I can just open this sheet metal rule, and inside the library right now we are using the cotton steel, right? And if I click on the edit, here you can see the thickness currently we had in our design is 2 millimeter. If I want to change that to 4 millimeter, I can just click on 4 and click on save and close. Here you can see the all design is being updated to 4 millimeter thickness. You can see the difference, right? If you cannot see the difference, I will show you again. I can again go back to library. So this is the rule that we are following right now. If you click on the edit, and if you want to change that to, let's say, we are using this one in this design. Here you can see this one is the rule that we are following. If you want to edit it, just click on the pencil icon over here, and we can change that to maybe 6 millimeter thick, and we'll click on the save. So here you can see the thickness is getting updated in just a single click. So how easy it is when you had designed this complete bracket in the sheet metal. So guys, if you have any questions about this design or any process, you can just comment below in the video. I'm always here to help you, or I'm always here to available here to help you on any of the process related to Fusion 360 design process.